All right, so we have spent a bunch of time working with using matrices to solve systems of equations. So you have the general idea of what a matrix represents. It represents an equation, right? So now we're going to go back and we're going to talk about some of the basic stuff that you can do with matrices. Okay, so this should feel like it's a little bit like, oh, breath of fresh air for a minute or two, because it'll feel like it's a little bit easier. And that's great. Okay, so let's talk about just some basics of matrices. First of all, when you name them, okay, we always name matrices with a capital letter. Okay, so capital letter, and you can see like these two, this is letter A, that's letter B, they're both capitals, and those are just the names that we give them. Okay, and then the individual numbers in your matrix are called terms. Okay, so the individual numbers are called terms. All right, so you can kind of see the way this is like lined up. So if this, we call this capital letter A, if that's the name of the matrix, then we refer to all the terms as A with then a little subscript. Okay, so these subscripts don't do anything. They're not like exponents where it's telling you to do a calculation. Okay, all that a subscript does is it just is a descriptor. Okay, so you can see that as you look at these, like notice how in the first row, every one of these starts with a 1. And in the second row, they all start with a 2. And in the third row, they all start with a 3. Okay, so the first number is just an indicator of what row you're in. And then see how in this first column, right, all the last numbers are 1s. And in the second column, all the last numbers are 2. And in the third column, all the last numbers are 3. Okay, so all that this is it's just it's a descriptor. It's telling you like, where's this term? How far over and how far down do you have to go? Kind of like plotting points. Okay, so the first number tells you which row you're in. Okay, so the first number tells you which row. So that's the row number. And then the second one tells you the column number. Okay. So when you look at a matrix like this guy here, right, I would call this one, if we call this A, we'll call this matrix A, then this would be term 1 or A sub 1, 1, right? So it's the first row, first column. This guy here would be A sub 1, 2, first row, second column. This would be A sub 1, 3, first row, third column, right? If we looked at, say, this guy right here, okay, this would be A sub 3, 1. Third row, first column. So it's always rows by columns, okay? Similarly, when we talk about matrices, we talk about the size of a matrix, which is going to be an important thing to talk about. There's certain things that only work when your matrices are the same size or when certain parts of their dimensions are the same. So when we name the size of a dimension, really easy, it's just the number of rows by the number of columns. So this one has 2 rows and 3 columns. So we call this a 2 by 3 matrix. Okay, and that's how you'd write it. But when you say this, you say that by. So it's a 2 by 3 matrix. This guy right here has 3 rows and 3 columns. So that's a 3 by 3 matrix. All right, and this one where you have the same number of rows and the same number of columns, this is also called a square matrix. Okay, those are important, and we will talk more about square matrices and why they're important at a later time. Okay, so a square matrix has the same number of rows and same number of columns. This guy right here, this one has 4 rows and 1 column. So it's a 4 by 1. Right? And since it only consists of 1 column, we call this a column matrix. This guy over here, we've got 1 row and 6 columns. So this is a 1 by 6 matrix. And similarly, because it's all in 1 row, we call it a row matrix. Okay, so just some fancy terms and how we do the dimensions. All right, so then we're going to look at 2 different things. We're going to look at adding / subtracting matrices, and then we're going to look at scalar multiplication of matrices, okay? If you are going to add 2 matrices together, they have to be the same size. That is a rule. So like this guy is a 2 by 3, and so is this guy. So they have to be the same. And then all you're going to do is you just add or subtract the numbers that are in the same spot, okay? So the same cells. So like in this guy, the first number here and the first number there, it's a 1 and a 0. So I'm going to add that together and get a 1 in the first spot. Okay, these 2 numbers, see how they're in the same spot? I'm going to add those together, write it in the same spot. These 2 numbers, I'm going to add those together, write them in the same spot. So this is really easy. 1 plus 7 is 8. 0 plus 5 is 5. 0 plus 0 is 0. Done. Same thing here, but with subtraction. Okay, one thing that you might find worthwhile is I find that often people forget to subtract when they have a subtraction problem where they have to keep subtracting, because we're going to have to do like 4 minus 5, and then negative 3 minus 6, and then 7 minus negative 7, and negative 1 minus 1. Okay, so what I recommend that you do, and you don't have to do this, but I do strongly recommend it, is change this to addition, and then just swap all the signs on these guys. And then you can just worry about the adding and you don't have to stress about the subtracting. Okay, because again, that's where people seem to screw up the most. You just, somewhere along the way, your brain will skip and forget to subtract. Okay, so now instead of doing 4 minus something, I'm doing 4 plus negative 5 is negative 1. Negative 3 plus negative 6 is negative 9. 7 plus 7 is 14. Negative 1 plus negative 1 is negative 2. So again, really easy. All right, and then this guy here. So this is an example of why it's a problem when they're not the same size, because you can see that these aren't the same size, right? So like I would add the 12 and the 12, and I'd add the 2 and the negative 3, but then when I go to do the 7, there's nothing to add to it, right? And it's not a 0, because if it were a 0, then we would have that number written in, right? Like we did on this one. So there's nothing to add the 7 with, and that's where our problem comes into play. Okay, so anytime you have two matrices that you're adding together and they're not the same sizes, then that is just undefined. Okay, so that is an undefined thing. You can't do it. All right, and then the last thing is scalar multiplication. So this is multiplying a matrix by a single number. We're going to talk later about how you multiply a matrix by another matrix. Okay, but basically all that you're doing is it's a giant distributive property. You just multiply this number by everything in this matrix. So I'm going to do 2 times 1 is 2. 2 times 8 is 16. 2 times negative 3 is negative 6. 2 times 4 is 8. 2 times negative 2 is negative 4. 2 times 5 is 10. Bam, we're done. Okay, same thing here. We're multiplying by 1/4, right? Well, 1/4 of 8 is 2, right? It's the same thing if it helps you. Multiplying by 1/4 is the same thing as doing 1 times 8 divided by 4, right? 1/4 of negative 12 is the same as 1 times negative 12 divided by 4. So that's negative 3. 1/4 of 16 is the same as 1 times negative 16 divided by 4. So negative 4. And then 1 times 4 is 4, divided by 4 is 1. And there we go. All right, so that is it. So this is some of the very basic stuff about matrices. Okay, we've kind of looked at why we bother with matrices and why they're useful, where we're looking at our systems of equations. And you'll kind of see a little bit more how some of these are useful as we go along. But this is just kind of going back to some of the like easy basic stuff that you can do with a matrix. Okay, so what you should be walking away from, you should be able to identify a term. So like if I give you a matrix and I say, okay, tell me what term B21 is, right? You should be able to look at it and be like, oh, well, that means that I need the second column in the first number, so it would be a 4. Okay, you should be able to label a matrix by its dimensions, row by column. You should be able to tell me if there's a fancy name for that matrix. Okay, add two matrices together and identify when you can't do that. And then a scalar multiplication, which is a giant distributive property.